So today we'll look at this Maxcom 4E. They're not the best sets. They're really reliable, good workhorses. The only letdown is the desensing on receive, which this chassis suffers from. So it's not like bleed over, it's when somebody's on another channel pretty close by, it knocks your sensitivity on the channel you're on. So Mark's been through this. When we get those out. 7 watts? No transmit light. Well, it'll take longer to do the transmit light than it will to do the rest of the set. So we'll take all the lids off, because we'll have to take the front off and take the front board out, and it's a bit of a faff because it's effectively hand wired. And it's one of the things that fails. I thought I'd get us started. I've got 15 minutes. So it's this chassis that's used in the Cobra 21 XFM, the Colt 295, the Midland Precision series, that's 2001, 3001, 4001, and quite a plethora of other sets. Then you've got a crystal filtered version as the Maxcom 30E. And if we sidetrack over to, is it the Donita 240, possibly a CPT set, and so is that Midland Power Max, whatever it is, 250K. I don't know why they called it Power Max, it's a marketing thing. I mean, 4 watts is 4 watts, isn't it? And most of the time these sets do 4 watts. Occasionally they do 3.8. There's nothing different in the circuitry on those Power Max other than it's got the crystal filter. And always, I've never seen a 2781 one of those which hasn't been a fake one. So just be aware that a lot of them were modified naughtily, and there you go. And they perform badly because of that. So this looks pretty genuine. 7 watts? Don't know what my meter will say, but that's what the meter Mark was using said. And now I'm eager to see this fabled 7 watts. They're not capable of that. When Mark tests these, he's given a hobby meter, not a commercial meter like we have here. As you know, we do these connectors. If you ever find them missing, we've got these on eBay, and we've got the other connector, and we've got the complete leads, which Mr. Chippy makes up with the correct tooling. They're not fake ones, they are the real thing. They're a bought-in part. Maxcom just bought them in. Brand new standard replacement mic with the right plug on the end. It's in lovely condition. So we'll power it up, but we'll need to plug in the test equipment speaker. We'll also plug in the speaker we have mounted on the wall in the PA socket. Right, power supply on. Pop it on channel 20. Switch picture in picture on, I'll tell you that just in case it doesn't appear. It's appeared on my monitor. And it's doing 4.8 watts, and it's banging across the meter because I can hear it. So that'll have to come down. On channel 1 it's 5 watts, and on channel 40 it is 3.4 watts, telling us it's actually unbalanced. You average that out and you're a lot nearer 4 watts than what that is. Right, back to channel 20. Low power, and it is doing 1.5 watts on low power, which is stupid. On high power, it's drawing 1.273 amps. Deviation, for what it's worth, on this test set, we were last on CPT, so I'll just have to retune the system. Wallow. It says 1.4, but we'll take that with a pinch of salt. We're not doing the VCO because you need to add 3 parts to meaningfully do the VCO. As I've said many times before, that these are manufactured and the board is tested without this wiring in on what they call a pin jig, and they do the adjustments so they don't have to put the extra parts in. That keeps costs down. Frequency, I've only had the test gear on about 10 minutes. We'll take that with a pinch of salt, but nevertheless we'll 2779100, and what we'll now do is to set the signal generator for the same frequency, and again it was on CPT last, so it's a faff putting it back. Right, signal generator on. Let's check PA. Testing 1, 2. Good. And now we will have a look at the SINAD meter, which I'll remember to switch on. I'm going to unplug the extension speaker which was in the public address socket, because it comes through, the way they've got this switched is ludicrous, and it comes through all the speakers all the time. Right, over to the SINAD meter. .64. 0.56. It's quite a hot day today. I've got the air conditioning on in here, if that's if you can hear that rumble. In fact, I've had to put 4 air conditioners on around the house. Luckily I've got solar panels. Oh, I had a letter from the electricity company saying they're putting the price down. Especially my night units. I have economy 7 here, being all electric. I think we're down to 16 pence a unit. Whoopie-doo. Not like the 3 pence a unit it was a few years ago. 20 dB. Yeah, it's not going to quite do it, is it? Not going to quite do it on the 1 scale. It's 3.8. Might be able to improve that. It really doesn't matter. It's just noise which is generated, but it can be the detector that's out. So squelch, let's put the squelch to full, and it's 10 microvolts, which is not very good. And let's look at it at minimum. You'd be fed up in a town with that. This is fine at the sensitive end, it's 0.48. Hopefully that'll just adjust. We'll just adjust. See what the S meter says. Sometimes they're adjustable, sometimes they're not adjustable. If it's not adjustable, we don't modify the set, or you're going to end up with a pile of sets that all have adjustable meters when not all of them should have. So that's where we should be for S9. So it's what you'd call a lazy needle, and it is 301 700 microvolts to get S9. Meter lamp works. He says the TX lamp didn't, he's right. No TX LED. What else have we got to do? Oh yeah, RF meter. Let's key it up. Oh, it bangs across. So we put FSD for full scale deflection in that box. Switches are fine, potentiometers are fine, sockets are fine, PA sockets fine, and there we have it. Let's just see if we can get this transmitter tuned up, and then I'll disappear off for lunch. Right, back to transmit. So it's the centre, we're on low power, it's the centre of the peak. We're on channel 20, we're in the centre of the band, centre of the peak. There you look right. There's a dry joint under here. Right, so next one, we're still making sure everything's peaking. At the moment we're doing 5 watts. I'm not showing you the right meter. So at the moment we're doing 5 watts, as I was saying. Let's put some more heat on that. So we've peaked it there, it's still 5. Then the radio power is this final one. So we'll need to turn that clockwise to reduce the power to 4 watts, which is there. Now we'll check it's within 0.1 of a watt on the band extremes. On channel 1 we've actually got 4.3, so that's not ideal. We'll definitely have a dry joint under there. One of these needs to be altered because we're a bit high on channel 1. It's actually 4.3. So is it this one that's slightly out? I think it is. That's 4.1. No, it's not that one. Is it the next one? Setting that again to 4.1. Yes, it's that one. So we've got, on channel 40 we've got 4, on channel 1 we've got 4.1. I'm sure Busby isn't going to come round for 0.1 of a watt, and it's within our measuring error acceptable limit. 4 watt, 4 watt, 4.1 watt, which is a damn sight better than where it was. Don't for any of you think, legality aside, don't ever think that 5 watts is 25% more range. It isn't. It's like 10 yards if you're lucky. It doesn't work like that. Low power. It should have a low power preset. It should be that one. So, yeah, it is. So what, 400 milliwatts on the preset there. And while we're doing that, if it should have a transmit one, which is going to be that one for the meter. Let's go back to full power. Oh, I've gone and said it's on channel 1, like an absolute numpty. Redo that. Now we're on the wrong preset. There goes the compressor on the air conditioner again. I bought this air conditioner in 1987. It's never played up. Came from Saudi Arabia. Right, back to full power. We want the meter to read something like the 4 watts it's doing. Which is there. So clearly got a dry joint somewhere. So there we are, that's that set. Just do the current consumption, 1.093. So 1.093, 400 milliwatts, and the meter reads 4. Right, we'll leave it at that. Come back to this later on. Right, we'll do the deviation. Wallow. Helps if we switch the radio back on. Wallow. Yeah, it's 2, it's low. It's the lower preset. Wallow. We've got a peak of 2.5 now. Go back onto the Marconi test set and see what it thinks now. Wow, yeah, it agrees. So it was actually 2. See where we are with frequency now. 2779 120, so it just needs a little bit. We'll have it slightly high, then it's got room to drop. So we've still got a dry joint on transmit. It's quite possible that it's been, if it's been operated at 5 watts, then it's going to have thrashed it and it's going to have melted some of the solder. We'll take the bottom off and have a look at that. I've got to take the bottom off to do the TX line. Right, let's get on with the receiver. So 2779 125. It's there somewhere. That'll do. Start with the detector. We'll go over to the oscilloscope for that. That was a bit out on this. Right, let's do the front end. Quite a difference there. We'll drop the attenuator. Little difference. Put a bigger signal on for this one. Right there. Right, set a new reading. So for 12 dB, I'm not even showing you the meter, am I? So for 12 dB we now got 0.46. That's well in there. Really, you're wanting it to be better than 1 microvolt for 10 dB. So we're very much in advance of that. 0.41. And if it'll do 20, it will now, you see. That'll be the detector which was out, 0.78, that's a massive difference. And that should make the squelch work better, that it wasn't working badly as it was. Right, full squelch, and let's get that set. So we want to tighten that up a bit. Not that tight. That's it, 100 microvolts. So we've got an S9 equivalent maximum squelch. Now we'll do the opposite. Check it with the at the bottom end. See where the squelch sensitivity is. Put the signal generator back on. Maybe I'll show you the attenuator. Signal generator back on. Parked at 0.3, it's come straight in. So it's 0.3. They're not usually as good as this. We've got an exceptional set here. Now I don't think we've got an adjustable meter, but if we have, no. So if you didn't have low power, the preset would be there. And sometimes they've added one, but this is early production, November 1981, and they didn't put one in. So let's see where our meter is now that the set's been tuned up. There's our S9, and it is ridiculously high. 520. Well, that's better than it was. Should be 100. We're not modifying the set, otherwise we've spoiled the fact that these are different. It's a bit like having a motor car, and imagine the same era, and from November to January from November 81 to January 82 you had a particular front grille, and then they changed the front grille, and then you've got all people fitting Mark II front grilles. It's not how it's supposed to be. Right, I'll see if we can chase this dry joint, and we'll take the front off and look into the... I'll do the light first because it's such a swine to do. Turn the power off, pull the knobs off. Can I do that with my fingers? You know what, I can't on this one. I'll have to get the string underneath them like I've shown you before. But first of all, I'll take these screws out. None of the tabs are broken on this set. It's actually immaculate, isn't it? Definitely got a dry joint though. That's been over tightened. That's one knob off. course there's no string on this bench, is there? We'll do it with the rough way with the screwdriver, just to, at the end of the day it's my set, not on wanting to ruin it. It's a bit of packing to protect the front. Handy bit of heat sink there. Good. This LED is such a swine to get to. Best course of action, top screws out. Front subboard screw out. We can tilt that slightly now. Hopefully that subboard will now push in. So you basically got this subboard with printers actually doesn't go anywhere, and so as soon as you unsolder that LED, these two wires come off. So we need to remember that the blue one's in the middle and the black one is underneath. We also need to put the soldering iron on, which I've just remembered to do. Put a dry joint just there. So clean it with the fiberglass brush. We've got a dry joint there. These don't suffer from dry joints, but we have to appreciate they're now 40 years old. It was just, sometimes when you keyed up it was just being a bit reluctant, and then as if the VCO was out, but it isn't the case. Right, so we'll take these off. So we've now got the subboard out. And then it's not labelled, so you've got to look at the anode and cathode and put something in the same way round, which I will just do. Right, so we've got to that position where I put the front back on. I did test it with that subboard dangling to make sure it was in the right way round, and there's the old LED, so it's a 3mm type. Well, we'll put the knobs back on. Oh well, if we could. There's Cybernet Beta 2000 on eBay at the moment for £200 not working with a wrong knob on it. I wonder what that's about. Right, there we go. Hopefully we've got rid of the dry joint. Power on. Press transmit. And we have a LED. Right, we'll just turn this on with the talkie-walkie. Testing 1, 2. We're not on channel. Oh, we're on CPT, aren't we? Testing 1, 2. Testing 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Want you to just make sure it doesn't go off. Yeah, there will be some microphony, but now I think we've cracked that dry joint. So it's nice to see one of these from the first batch from 1981. As I record this in 2024, end of June, another 6 months. What will this be, 43 years old? Oops. So those of you who get excited about the Midland 4001 with its superb looking case and front in blue, we did a video on the RAL colour that is. No guessing, it does have a RAL colour, and just remember this is what is inside. So you can't say, oh, I think the Midland 4001 is an absolutely brilliant performing set, and I hate Maxcom 4Es, because it's the same. So when they did the 30, they added a crystal filter. I've actually found the 30 to be the least reliable. I don't know why that was. Perhaps their production techniques had slipped in those years between 1987. We did the 16E the other day, we did the 21E. We've done, I'll tell you what we haven't done for a bit, we haven't done a 6E for a bit. We've got a 20 on the shelf with a broken front, so I can't really do anything with that. We've got, I showed you my, I'll be using it as a comparison, I showed you my Rotel RVC 240, and one of our viewers is kindly sending me a front. He's actually one of our trade dealers, but so that's going to be good, because we'll be able to sort out my what did I just say? Rotel RVC 240, which I've had think I bought it about 2010 or 2014, so we've certainly had it on the shelf a long time with a broken front, and it would be nice to get that finished. I seem to think I paid £37 for it with a broken front. Right, there we go. So we'll unclip it from, I wonder if the speaker works. Yep. So we'll unclip it from the test equipment. And put the squelch on. And plug it into the aerial. So as I say, we do these proper power leads, but I don't need to for this demonstration. 19 Roger. All there is foreign interference. So it's a very sensitive set for these. What did we come up with eventually? 0.46 microvolts. That's done, and the speaker's done, and that's not applicable because we're using a brand new one. So thank you for watching the 1981 Maxcom 4E. It lives again.